From a total of 11 languages and dialects used in Egypt, 2 are non-spoken. The Arabic and Egyptian Sign Languages are currently the only known means of communication for a population of more than 7.5 million people living in Egypt. For this reason, we have chosen to construct a two-way communication system to accommodate the deaf and the hard of hearing. Our main objective is reducing the number of difficulties the deaf and the dumb communities face on a daily basis by both giving them a voice and a method of understanding a speaking person. Our project can be divided into 2 parts: a smart glove system responsible for translating the sign language gestures into their corresponding Arabic letters and words to be then displayed in both text and audio forms on a simply designed mobile application or web page.
مرحبا.
And a 3D printed human-like arm system with 2 degrees of freedom and a voice recognition algorithm that converts spoken Arabic into their respective sign language. We used an MCP3008 ADC chip to enable us to read the analog values of 5 Flix sensors placed in their designated pockets on the glove worn by the disabled person, along with an accelerometer and 2 touch sensors that are placed in specific locations on the glove to distinguish between similar gestures. The data configuration is sent to the Raspberry Pi for processing and fed to the neural network, which is designed to predict the Arabic letter or word. This predicted output is then sent to the web page where a simple press of a button will display the text or the audio. For the ARM system, a similar button will be supplied to the mobile application or web page to enable voice input. This input will then be passed to a speech recognition algorithm that will translate it to text to appear on the screen, as well as generate the suitable servomotor angles to display the corresponding sign language gesture on the arm. For the PWM required by the motors, we used an Arduino Uno to provide PWM pins. The used neural network model is a convolutional neural network that can classify the input sensor configuration to its corresponding Arabic equivalent. For our current progress with the glove subsystem, we have designed a glove from a flexible material that can still hold its shape. We were able to implement separate compartments or pockets for the flex sensors and the accelerometer. From there, we have generated the dataset for all 28 Arabic letters from the combination of values from these sensors. 2 pockets were also designed for the touch sensors and are attached to the inside of the pointer and the middle fingers. With the ARM subsystem, we have 3D printed a human-like arm design with fingers that can close all the way to permit 3 positions of bending for each finger. Through strong thread and servomotors, all 5 fingers and wrist can be moved. This current phase of the arm can spell out complete words.
ميم هاء ميم دال مهند.
In the end, it's important to emphasize that hard of hearing and speech impaired people are not a minority. And with the current progress in technology, it's our role to do our best to provide them with their basic human needs of being understood. Thank you for your consideration.